Welcome to the lab, folks. Today we're going to do something, well, just a little bit different than what we normally do. So, my wife and I love camping, but we don't like tents. I know that sounds unusual, but as you get older, sleeping on the ground becomes, well, not very pleasant. And setting up tents in the rain at night is not very pleasant. So, we got ourselves what's called a teardrop trailer. And we just picked that up this July. We had to go from Ontario to New Brunswick to pick it up and back again. So that was our first trip in it. And one of the things that we want to do is we want to add in a solar supplemental power source. And I have experience with these before. I'm going to use this solar controller here, solar charge controller. I bought this, it'd have to be maybe 12 years ago. This dates back to a time where my son was a professional level racer in the off-road community. And we had a big trailer. We had a 20-foot aluminum trailer to house his bikes, and it had a living compartment in it. And we used, solar power to supplement our lighting needs and stuff like that then too. And the charge controller we had then went kaput. And so I ordered this one up. I think I got it off eBay. I have no idea. I can't remember that far back. And it came in, but by that time my son had changed his mind about riding at a racing level all the time. So we ended up selling the trailer a couple of years later, and this never got put into use. So it's been sitting around all that time. Now I do believe it was a considerable upgrade on the charge controller I had before. I only had it was only a little thing like that. Now this is supposed to be either 12 or 24 volts. It's supposed to switch automatically. And this model is a 10 amp model. And I do believe that the same basic controller can be had in 20 and possibly even 30 amp models too. And this is the solar panel I had back then. It's only a 15 watt solar panel. Okay, so here we're outside, and I've got the solar cell propped up on the back of my truck here. The angle's not quite perfect towards the sun, and of course the sun is pretty low in the sky this time of year. So we're not going to be able to get the absolute maximum performance out of this, but if we have a look at it here, we got a short circuit current of 1 amp, and just 1 second here, I'm going to switch to voltage. Okay, and we've got an open circuit voltage of 21.5. So yeah, I'm fairly confident that the specifications on this solar cell are right for optimal conditions. This is a proper 15 watt solar cell. And the rated current is 0.87 amps. So as 15 watts, it is 17.28 volts and 0.87 amps. So one thing I want to do is I want to have a look inside this thing, because I noticed that there's this screw here is rusty. So I just want to make sure that nothing got wet inside it, and I have to replace it before I ever use it. There's only 2 screws to get into the main case here, so that should be easy enough to have a look at it. Also be nice to see how they did this back then. I mean, that's going back quite a few years. No clips, just kind of a tight fit. Okay. Well, just at a glance here, it does not look like any water got inside it, so that's good. So it should work. I'm going to hook everything up, but today is an awfully cloudy day, so I'm not going to be able to get anything out of the solar panel. So I'm just going to use a power supply to kind of fit in there, just to see if it'll charge and all that sort of stuff. But just looking at it here, let's see if I'm going to use this magnifying glass over the side here, so I'll be popping back and forth. All right, this thing here is a polyfuse. Look at that number. Yeah, it's a polyfuse. It's a GF1200 16 volt 12 amp. So that looks like it's perfectly fine for 10 amps. This is a MOV down here. Now that's on the solar cell input side. So I guess just in case of a lightning strike or something, maybe that MOV's there. This chip looks like it's in the center of things. Let me have a look at that. That's just a good old LM324 quad operational amplifier. They're like the 358. They're optimized for a single volt supply. Okay, this chip here, it's digital, but I don't think this is a digital device. This is a 40106, which is just a hex Schmidt trigger inverter. And let's have a look. What's this thing here? It looks like an optocoupler. Yeah, this is a JC817 optocoupler with 5 kilovolts of isolation. And these MOSFETs along the back here, okay, they're all the same. They're International Rectifier IRF 3205 N-channel power MOSFETs. They're rated at 55 volts, 110 amps. Wow. They've got an RDS of 8 milliohms. They seem to be huge overkill for the situation. I guess that's in consideration of the fairly small heatsink, but I think at 10 amps that's not going to be an issue at all. And they're all the same. That's a pretty good design in my book. So all the positives are common here. So all the control is done on the low side, and that's coming down and going through that diode. So that's just a anti-backup diode, so that voltage doesn't get into the solar cell. And this transistor here, okay, that's a D887 NPN high gain medium power transistor. It's got 60 volts, 4 amps, good for 40 watts, up to 50 megahertz, and a pretty decent gain on it. I don't remember the spec, but I think it's like 500 or something like that. I could be wrong. Check it up. And the rest of the components look really good, like all those little barrel diodes in there and everything else. I mean, there's nothing looks shoddy here. I did notice when I had this peeled back here, I mean, this here is the input, and they put a MOV on it. The only thing I can assume is that they're expecting lightning strikes or some other high voltage getting in, but they didn't leave a lot of spacing here between the traces. So I think if it gets a hard enough hit, you're going to get arcing across here. And all these MOSFETs have the low side is common, except for this one over here. And this one's also isolated from the heatsink. So that looks like it is associated with the output. So that's the output that's going to the load. So that MOSFET controls the load. These MOSFETs here control the input and control the power going to the battery. And this controls the power coming in from the solar cell itself. It looks like the space for more here. So that looks like how they get it up at least to the next level, up to the 20 amp version, just double everything up. And over here is a W1 and a W2. So there's a control here that they haven't installed in this one. I don't know what this controller here does. I would hate to screw around with it unless this thing doesn't work right at all, and then I might try to figure out what it does. It looks like this could be reverse engineered, although I'm not about to try and do that because it's not going to be an easy reverse engineering job, but it could be done. All right, well this actually looks pretty good, so I'm just going to put this back together and try and get everything hooked up and give everything kind of a little test. To make sure everything's going to work for me when I go away on my next trip. Okay, I'll come right back when I got this back together and get some leads hooked up to it. One thing I want to point out before I put the case back on it, cover back on it, is this says here 2010 1025. So I guess that's an revision 1. So that was the revision from back then. And it has MC MP12-24.PCB, and it says CMP 1224 on here. Now I notice that the ones available today, no matter where I go, don't have the 24. They just have the 12. But they do talk about in the blurb about them that they're automatic switching between 12 and 24. Is that true? I don't know. And do the circuit boards in them look like this? Again, I don't know, unfortunately. All right, I'll get this back together. All right, so I've got everything set up here in order to test this thing out. I've got this load here. I'm going to use it in rheostat mode. I don't have it plugged in yet. And I'm going to then turn it up to about a half an amp, because that's basically what our load is around about a half an amp with the LED lighting that we have. And I have the power supply here acting as though it was a solar panel, because right now it's hailing outside. and it's about as dark as twilight out there. What I'm going to do, I've set up the power supply 17.28 volts and put a current limit of 0.87 amps on it. And that should kind of, let us see what this solar cell will be capable of doing. According to the instructions that come with this, I've connected up the battery, and I'm going to connect it up first. This humongous battery here is my battery I use in my trailer. And I've got this meter here is going to measure the load, and this meter here is going to measure the current coming in from the solar cell. Okay, so now we have to connect up the battery first, and we'll see it's got a battery condition indicator here, and we'll see what lights come on when we connect that up. Okay, so our battery is in fair condition, needs a bit of charging, and the controller is in load mode. So actually, let's hook up a load. Let's hook this up. I want to get this, turn it up to like 0.5 amp. So we've got 1/4 amp going through it now. So let's turn it up to 0.5 amp. Yeah, that's good. And so it is supplying the load from the battery. Now let's turn on that power supply, and here we go. So okay, so it's putting 870 milliamps into it, and the charge lights come on. And I guess the only thing now to test, everything seems to be working fine except for, is it going to charge up the battery to full charge, and when is the charge going to automatically go off? So I think it would take a lot longer with the load on it, if that's going to happen at all. So I'm going to take the load off it here. So here, let me disconnect this here, and I'm just going to let it run. I'll come back to it when it's charged, if it's charged. So I'll give it a couple of hours, but I'm not going to bother time lapsing that. That won't be very interesting. We'll see you in a couple of hours. Okay, well, it has finished charging, but it's being powered by a power supply and not a solar cell. So the power supply relay is switching back and forth very fast here. So I'm going to take the load off it, or the power off it. And so it's about 14.15 volts that is going to stop charging. I'm sure it'll do a better job with a solar cell attached to it, and it'll probably bring it out to about 14.2, but I'm just imagining that right now. I don't know that for sure. But 14.15 volts is perfectly acceptable, I think. And if not, I can always try adjusting that little pot in there that we showed you earlier. But okay, well, that's it. So it looks like this charge controller and my solar cell and this battery here are going to end up being a pretty good supplemental power source for our reading lights and whatever have you, cooking lights and stuff like that in the trailer. And yeah, that's excellent. I'm going to install that as soon as the weather gets a little bit better, and we're going to be off camping. Thanks very much for coming out and joining us today, folks. I really appreciate it, and we'll see you in the next video. By the way, if you like this video, please leave a thumbs up, subscribe, because I do some interesting stuff around here, and if you really liked it, post it on your favorite social media site and help out the channel for me a bit. Thank you very much. Bye.